Pleased to introduce Mark Martinez to start us off. Mark is a senior portfolio manager for SCE with over 30 years experience in the research, policy compliance, and deployment of electric demand-side management enabling technologies. He oversees SCE's emerging markets and technology program, which includes intaking and assessing new enabling technologies for demand response and dynamic pricing programs, and distributed energy resources such as batteries and electric vehicles to support market transformation. Thanks again for joining us today, and I will hand it over to Mark to kick us off.
Thank you, Jonah. Thank you so much, and welcome everybody to yet another session of the Demand Response Emerging Technologies webinars. We're very glad to be able to share not only the mission of DRET, but also some of the activities that we've had recently that are looking forward to a future of demand flexibility as well as grid integration and renewables and so forth. So next slide, please. So the DRET programs are actually 3 individual programs funded by the CPUC for the 3 electric investor-owned utilities. Each utility funds their programs, but we use the DRET as a means to coordinate and collaborate with each other. We do enabling technology research, market assessments for customer technologies and processes and so forth. The electric utilities, we don't manufacture air conditioners or electric vehicles or things like that, but our customers do. And our customers want to be able to have the resources to be able to utilize those assets. And we want them to be partners in grid reliability with us. So through demand response programs, we can facilitate that. The current DRET funding cycle is through 2024 and 27, and it's been authorized by the PUC. And so being able to collaborate on these really gives us a future where enabling technologies, new types of software and programs can be enabled for our customers in the coming years. Next slide, please. The purpose of DRET really is to accelerate DR adoption. So when you look at how customers are engaged with their technologies, business as usual takes a while for customers to adopt innovative technologies. We're all conservative. We don't want to be the first ones out of the gate. However, we're able to influence, for example, a good example would be, for example, air conditioners or heat pumps or heat pump water heaters. By letting the manufacturers know that there's a capability for their appliance or their technology to be utilized in a program, we can encourage them to be able to, make some adjustments or make some changes and so forth. So incentive programs perhaps can incentivize customers to, reduce the cost of their first purchase. But with the DRET intervention, we can actually work further upstream to be able to influence manufacturers. There's a lot of examples of that. Next slide, please. What we've done in the past, for example, is looking at behind-the-meter technology programs. So customers put in solar panels, they buy electric vehicles, and they buy smart thermostats and so forth, and they install batteries for their solar panels. Well, all of these technologies behind the meter can be utilized by the customers. We don't want to force anybody to, turn things on or off, but as partners in a grid program, they can really facilitate some virtual power plant performance or other things through automated demand response. And then utilizing open communication softwares, everything talks nowadays, and we've seen in codes and standards how those things are happening. We really want to make sure that customers can participate in our programs through the open technologies that are available. And then, of course, the load flexibility is the new pathway for grid reliability. It's not so much that you utilize your appliance or your technologies all the time, but being able to respond to grid needs. And as we say, how does the grid articulate its needs? Well, it's through our pricing programs. And those are the things which we really want to be able to facilitate in the future. So we're looking forward to a future where our partners can be our customers in providing grid reliability and resilience and cost affordability. So next slide, please. So with that, I'll turn it over to Jeff, and Jeff is going to talk about one of the projects that are in the DRET, and have a go at it, Jeff. Yeah, you're up there.
All right, thank you, Mark. We're just dealing with some technology this morning, so we're getting there. Bear with us here. All right. Well, thank you so much all for joining us. It's a pleasure to be here today and provide an overview of a couple of our projects here at San Diego Gas and Electric. So I'm a project manager on our emerging technologies team here at SDG&E. That's within our customer programs department. My focus is on evaluating technologies for demand response. So today we're going to go over two projects. The first is a managed electric vehicle charging demonstration that we've completed, as well as a smart panel study that is underway. So next slide, please. So this EV charging demonstration was one that we did this past year. It was very small scale. We recruited about 20 customer EV drivers to really give SDG&E our first experience with telematics data with managed charging. So this was a great opportunity for us. We worked with a vendor that had the full platform where we recruited customers, pointed them to the vendor's platform, had them enroll, and we actually successfully did managed charging events during demand response season. So the whole goal of this, like I said, was largely to get familiar with the technology before we look at doing this broader. We were just thinking there would be a lot of considerations we want to be mindful of in terms of how we recruit. And sure enough, the things that we learned were sort of what we had hypothesized, but it was just a great experience for us to really try it firsthand. So we worked very closely with our clean transportation team on this project. We recruited the customers. It was the second quarter of last year when this kind of got underway. We did the demand response testing in third quarter, and we wrapped up the analysis before the end of the year. And so, like I said, this is going to really inform some future managed charging initiatives that SDG&E is looking at. Next slide, please. So this is just a high-level overview of the process that we went through. Like I said, super small scale in the sense of 20 EV drivers is who we recruited. So we, again, got this contracted last year, wrapped it up last year. We did signal the events when DR events were called. So that was important for us to be able to do this during demand response season. And we did look at, obviously rate differences for the participating EV drivers. That was definitely a key consideration that we'll talk about here with a couple of the findings. But we had the vendor provide the analysis with the telematics data so that we could see the customer's charging behavior prior to each event, during the event, as well as following the event, just to see what customers were doing. Next slide, please. So in terms of the learnings and experience, again, we didn't do a full evaluation report. So like, you're not going to find this on the website. And that's because we did this as what we call an activity and not a traditional project. So activities generally don't get the full report. They tend to be more faster track initiatives like this, where we're trying to do something on a smaller scale and also relatively quickly. So like I said, we did this during DR season. We had 7 events scheduled in August and September of last year. Anywhere from 20% to 50% of the EVs were plugged in during each of the events. So you can see we didn't get anywhere near 100% for any event. So that was interesting. 10% of the EVs were actually charging during some of the DR events. So that meant that the customer had opted out, overrode the notification and decided to go on and charge, even though the event was called. When you look at managed charging and talk about doing it, across the board on a real large scale effort, there's really some things you got to keep in mind, especially with the rate. So broad TOU rate adoption, of course, these days does limit the ability to be able to shift during demand response events. And of course, the reason for that is that the peak price is quite high on the TOU rate. So like SDG&E has an electric vehicle TOU 5 rate, for example. Many EV drivers are on that rate. They do pay the highest peak price from 4 to 9 p.m. So because of that, they're already naturally not doing as much charging as perhaps an EV driver that might be on a domestic rate, which is not TOU based. So again, not too surprising in terms of what we saw, but this kind of confirmed our strategy for how we need to look at this in the future. So broad marketing and recruitment, again, could definitely lead to lower demand reduction than expected. So definitely something to be mindful of. The recruitment does also need to be mindful of electric vehicle manufacturer compatibility issues. We ran into kind of a series of things very interesting with very small group of EV drivers. We had one customer who was not able to participate because their EV manufacturer had a subscription fee that person needed to actually opt into to be able to receive a signal and participate in managed charging. And I think it was somewhere around $40, something like that. So when you look at EV compatibility issues, this was something that we very quickly realized is an issue, because I was a customer who was interested in participating, actually had multiple EVs, but we had to decline because they admittedly we just we didn't offer any kind of incentives for this. This was just kind of first brush managed charging, so just trying to really test it on a small scale. So if you're looking at doing incentives, you got to keep in mind that potentially you've got to try to cover that cost for the customer, or at least demonstrate the value and the benefit so that they can justify paying that fee. And from what I understand, that fee actually can range drastically. So what we saw for the one driver is not necessarily indicative of what some manufacturers might charge. And then others might actually include this as part of their EV, or they might only include it for a finite period of time, maybe 1 year, 2 years, 5 years. So it's definitely something to keep in mind when signaling EVs. So as I mentioned, the rate is of course huge. So targeting customers on a non-TOU rate, what we saw based on customers who were not on a TOU rate, we could get anywhere from about 1 to 1.5 kilowatt load shifting potential during an event. So again, really small scale, but we were really happy with the experience that we gained from this, because it confirmed a lot of things, but also just kind of really reiterates what we need to be mindful of. So we are at SDG looking at doing some other things with managed charging. We're looking at load detection possibly being integrated with managed charging. So probably more to come on that the next time we get to speak. But yeah, so we'll move on to our second project. And it's a smart panel study. And of course, we'll take questions on both of these following this next presentation. So if you have any questions on managed charging, feel free to hang on to those. So the smart panel study is one that's actually underway. We launched this one last year as well. And this was launched in conjunction with CalNext, the statewide electric energy efficiency emerging technologies program. So CalNext is doing a project from the energy efficiency and electrification perspective. And we basically decided to collaborate with them and do a joint project to focus on the load management and demand response benefits, the potential benefits of smart panel technologies. So what we're doing is really trying to understand the capabilities. We're hoping to work with 4 different manufacturers at 4 different residential sites, so we can get a very brief, like small sample size, but just a flavor for kind of the potential benefits that you might be able to realize with smart panel technologies. So this includes throttling, managing circuit level power through the software and programming that each smart panel technology offers. We want to look at those circuit level controls and really try to see how they can allow the system to shut off various combinations of non-critical loads. And of course, these non-critical loads will be configured based on customer preferences as well at the time of installation. And we also want to see whether the smart panels can help control renewable and stored energy, for greater resiliency benefit, and of course, other load flex purposes. Next slide, please. So in terms of the approach, we're identifying these host sites. We're looking at where they are at on the electrification journey as well. As I mentioned, we're definitely interested in making sure the customers have solar and battery storage, ideally. And then we also want like an electric vehicle charger involved, as well as perhaps some heat pump technologies, just to really try to maximize, the benefits and really look at customers that are further along on the electrification journey. So again, this is all residential, single family residential is the focus for this project. These smart panels might not necessarily replace a customer's panel. So when it comes to smart panels, there's kind of 2 different types, or 2 different primary installation types, you could say. One is where it actually replaces the customer's existing electric panel. And then the other more common approach we're kind of realizing is it's a complementary smart panel that doesn't replace the customer's panel, but it ties into it to do the load management control and offer that functionality. So in terms of the research questions, these are just a few of the research questions that we're looking at. Can these smart panels allow the dynamic control of critical loads by controlling circuit ampacity? Do the smart panels allow unwanted circuits to be turned off during an event or outage? So when we talk about events and outages, of course, we're talking about demand response events as well as other grid conditions. And then can these smart panels allow for dynamic control of certain non-critical loads during demand response events or other grid conditions? And then of course, can the smart panels manage that solar and or battery storage system that the customers have? And how does that get monitored through the smart panel system? So each of these types that we're looking at has various configurations and of course, various functionality that's customer facing. We're also looking at the utility facing side of it to see like what can the utility do directly. So yeah, pretty exciting project. As you know, there's been a lot of work in this space. PG&E has done a laboratory study on smart panels. SCE did a market assessment of smart panels a couple of years ago. So really, this project is really leveraging that research and building on it. So we're very excited to have this field demonstration project underway. And I think that's, oh no, there was one more slide. Yeah, so in terms of the expected outcomes, obviously it's underway. So we've got the installations are expected to hopefully take place in Q2 of this year. So we're finalizing the customer recruitment as we speak. The vendor contracts are basically in place. The installation contract is being finalized. But yeah, we've got a good sense of who the customers are that want to participate. The manufacturers are very interested in working with us on this. So that's very exciting to see that the industry is also very much aligned with us in this. So yeah, very exciting. This project will have a full report out as we normally do with projects. So once this project is completed, we will report out that project report on the ETCC website as well as the DRET website that Mark mentioned. And I think that's the final slide.
Okay, Jeff, since we have a couple of minutes, there are a couple of questions that have come in.
Right.
For the first project, who was the vendor? And is the $40 a first time, one-time fee or per transaction?
It was, if I remember right, it was either a monthly fee or an annual fee. Yeah, it's a great question. The fee structures did vary, but yeah, it's a good question. They did vary though. This particular one was for one vehicle type, one manufacturer, but then the more we looked at it, we were asking around, we learned other manufacturers have similar fees. But again, many of them were actually after a certain period of time, meaning like you buy the EV, it comes with this functionality for X number of years, and then it would stop at a certain point. So yeah, definitely something to be mindful of.
Okay, and then
in terms of the vendor, Jonna, it was a vendor called Flex Charging was the platform that we used.
Okay.
Sorry, I missed that first question.
No, that's okay. We have 2 minutes. So another question on the EV project. Can you talk about the approach and challenges in estimating the baseline for the DR events? Does it not look like a 10-10 or similar approach is appropriate given the daily variability in charging?
Yeah, great question. It is pretty tricky when you look at the baseline for this, as you can imagine. So what we did was, I didn't really mention on the slide because you get kind of deep on this conversation, but the short answer is we did a 10-day baseline of like days because we had events on both weekdays, non-holidays, as well as weekend. So what we did was we did a 10-day baseline for that day type. So if it's a weekday event, non-holiday, we took the 10 previous days, use that as the baseline. It is very tricky with EV charging because it's very dynamic. As you saw, we only got up to 50% of the vehicles plugged in for any given event. So not every EV is going to be plugged in every time you call an event. So it's a very dynamic situation, literally. So yeah, the baseline's tricky, but we did a 10-day baseline.
Okay, thank you, Jeff. There are more questions for you, both on the smart panel study, but we'll hand it over to John for his presentation and come back to you later.
Great.
At the end of the Q&A. Thank you.
Okay, thanks everybody.
Well, thank you, John. And let me give the group a brief intro. First of all, I want to introduce John Powers, and he's the Chief Strategy Officer and founder of Velexity. But John's history goes back many years. He's been involved with the early days of demand response and different types of programs. John's been a great partner over the years. And we're going to be talking a little bit about a couple of programs. As I indicated, demand flexibility is sort of the new realm of what we're looking for. And because we're moving towards electrification and renewables integration, we need more dynamic responsiveness to how the grid articulates its needs. The projects that John's involved with now are really going to shine a light on how we can use innovative technologies to be able to meet those needs. So the bit of the introduction here, John's working on both the CalFlex Hub, which is a CEC demonstration project over at Lawrence Berkeley Laboratories, but he's also been a great partner in Edison's dynamic rate pilot. This is a pilot that we did where we actually used day-ahead hourly pricing, sending those prices to customers. So what's the customer supposed to do? Well, John will explain how he enabled customer response to that. And it's coming soon to a California utility near you as we filed applications for dynamic pricing. So with that introduction, I'll let John continue his story. Thank you.
I really appreciate the intro, Mark, and the context there. Yeah, I will, in fact, talk about those two projects, and in particular on the CalFuse, or the dynamic rate pilot project for SCE. We'll talk about taking day-ahead hourly pricing all the way down to the end customer level. I like to tell people that I've been around the industry for a while, and more has changed in the last 3 years than in the 30 before that. Hourly pricing all the way to retail customers is better than fusion for a simple country economist like me. So let me make sure I am sharing the right thing. Let's share a screen like...
Nope, you had it before.
I did? Well, let's do it again. That should do it. There we go. All good?
Looks good.
All right. So the need is great. I think Mark teed this up right. The grid is changing fast and needs to convey to customers that its needs vary from minute to minute and hour to hour. We used to just throw some more dinosaur juice on the fire to meet any level of load, but now with more of a supply following requirement for load, we're going to need a massive amount of load flexibility, or the energy transition we're all involved in will grind to a halt. So I will not beat that horse because I think everybody here knows it. So we work with commercial customers, small to medium commercial customers, because we like a hard challenge. That first quote is definitely something no customer has ever said. No customer is in this in order to help the grid out. They're there to teach the kids, to sell the cars, to move the sneakers, and not to help out the grid. So if the grid needs more flexibility from the behind the meter, we have to be able to give it to them in a way that they absolutely want, need, appreciate, love the technology that is going to save the money and meet the needs of the grid. This industry calls things distributed energy resources, but customers don't. They say, mine, my solar, my battery, my HVAC, my car chargers. So we have to really meet the customers where they are, not where we wish they were. And we take a very customer first approach to optimization. So we're trying to show how customers can increase comfort and convenience while delivering services back to the grid. That's the only way that, in my experience, the flexibility will be there when the grid needs it. We do that with software. We have a platform that manages energy, all the energy behind the meter. So HVAC, solar, storage, EV charging. We're not really big on prices to devices. We're prices to the customer. The customer owns all of these devices, and the customer should be able to decide what device is meeting grid load at any given time. So, like I said, we're a software company. We offer a flat monthly fee with guaranteed savings to customers, and we've also opportunistically been selling batteries because batteries have become way more cost effective since NEM 3 and the ITC and all that. Customer first means you have to sort of start with comfort, and control, and then move on to cost and carbon. We call those the 4 Cs of energy management. It gives customers an increased visibility into how they're using energy. They can see behind a single screen all the different parts of their energy systems, and we promise to get them into the best utility programs for their need, best rate, best incentives, all that. We take this whole building approach because customers, again, they have a limited attention span. They don't think about energy very often. They don't want to. That quote is real. I can't manage a bag of energy parts. It was something one of our customers told us. So anyway, they want somebody to take all the tough decisions off their plate and do it for them. And that is what Mark has, I think, very cleverly called an automation service provider. So we automate the control of all these devices behind the meter to make the customer happy, comfortable, and hopefully make them some money. So that's the role we play on the dynamic rate pilot that Mark just mentioned. We've enrolled multiple commercial customers, schools, auto dealers, retail outlets, fitness centers into that program. And we control in this project mostly HVAC. So in a small to medium building, that's probably package units or heat pumps. We can interface with building management systems, but really things get trickier there. So for a scalable program, you really want to target the broadest possible set of equipment. And in California, that's heat pumps and package units. We do have one battery enrolled in the program that came fairly late. I'm not going to talk about control of that battery today, just to sort of keep things moving. On the CalFlex Hub project at Lawrence Berkeley Lab, we play a similar role. We've enrolled some new customers. We did in sort of the first round at CalFlex Hub, we did a technology test in pre-existing buildings with our partner, UC Davis. We love UC Davis, but the buildings were not particularly realistic in terms of the way typical commercial buildings perform. So in this next round of experiments, we're going to we have enrolled 2 auto dealerships with level 2 chargers and HVAC, and we'll see how they perform. Here's a picture of one site where they're in SDG&E territory. They have a not very large solar installation, 13 heat pumps controlled by 13 separate thermostats, and they have at least one, and we're trying to figure out if they've installed another level 2 charger, and we'll be controlling all of those in response to prices from the Midas price server that's part of the CalFlex Hub project. There's the roof, there's the car charger, there's their baseline, there's their winter baseline. We can, I'll have real results from them next time, but we also are enrolling a second site on SCE's GS3 rate. No solar at this site, bigger site, so more heat pumps, multiple EV chargers accessible by API. We'll be controlling those as well. Midas sends the price signals that we'll be using to shift from hour to hour. So we look for the time period with the largest price differential because that's where the customer will make the most money. So if you want to buy low and sell high, and I'll get into that in a second. Yeah, there it is. So the load control strategy in any of these sort of customer-facing programs has to make sense to the customer. We buy or use more electricity during the period when prices are low, and we use less when prices are high. With HVAC, that's quite tricky. You can't just use the cheapest power of the day to offset the most expensive power. You have to find times that are adjacent. So pre-cooling or preheating only lasts so long in a building. So we build a thermal model of each site to assess how much HVAC can be shifted from hour to hour. So certainly you could imagine that a LEED platinum building with a lot of heavy mass might be a multi-hour thermal battery, a way to shift 4 or 5 hours of load. A drafty barn might be a half hour, and a typical commercial building, from our experience, is in that sort of 2 to 3 hour shiftable thermal capacity. And the rule of thumb we use for medium commercial buildings is that half the connected load of the HVAC systems can be shifted by 2 hours. So that sort of pushes out a control strategy. You find the highest price difference in adjacent 2-hour windows. When it's going to be expensive for 2 hours, the 2 hours before that is when you can use more to avoid using as much in that most expensive window. And all this has to be done with no customer intervention. There's a limit. Everybody says pre-cooling is easy. I've never understood that. Pre-cooling is quite challenging to be able to do in a way that keeps customers comfortable and works in the correct zones that you can actually defer enough HVAC to be meaningful. So we have a pretty extensive thermal modeling and optimization algorithm running behind all of this. But that's not the hard part. The hard part is explaining all this to customers, because if you really go in there with hourly prices, this, subscription, that, wholesale market, distribution congestion, all these things, the response from customers is bewilderment. And so our message is simply we'll control your building, so you use some more when prices are low and less when prices are high. And that they seem to like. So we've let this guy prattle on for almost 15 minutes. Surely we're going to show some load shapes, right? Yes, we are. So here's a SCE dynamic rate pilot HVAC load profile in June. And if you blink and squint, you can kind of see that we're pre-cooling there and relaxing the cooling into the most expensive time of day, which is almost always from 6 to 8 p.m. in the summer in California. This is what we're trying to do, but it is not what I would call a super impressive result. So here's the next month, and now you can see things are a little better. You can see a much more distinct pre-cooling period and a much lower period where we've sort of let the temperature start to drift back up for those 2 hours where prices are highest. And actually, by August, you can see that we are, as I think I said, printing money. We are buying cheap power and using it to defer the purchase of expensive power. And we have definitely achieved that. At least half the HVAC loads have been deferred for, a full 2 hours. And then September, same deal, maybe even better. We got a few days. These are average values over the entire month. Customers open every day, so there's not a big difference between weekdays and weekends. And we get a nice big decrease in that important 6 to 8 period. I just want to close with an observation that you can probably figure out from looking at this. Energy efficiency that we all know and love and have worked in for many years, that is about hardware. Once you replace the light bulb, it stays replaced. Load flexibility is about software. Software is what we need to respond differently on different days with different prices. Software is, in fact, the driver of California's economy at this point. Hardware gets worse over time. Software improves over time, as I think I just showed. Every other industry has caught on to this. The utility industry has been slow to adopt software as a primary means of addressing its primary problems. So I definitely appreciate the opportunity to address this crowd and say, where are the programs to encourage greater software adoption on the customer side of the meter? So that is where I will leave it, and I will take questions.
Okay, great, John. You've had a few come in. Would it be easy to include and control lighting of a building to Alexity?
It would be somewhat easy in some buildings, right? So none of this is particularly easy. We had to replace dumb thermostats with smart thermostats in most of the buildings enrolled in this program because many types of thermostats do not communicate with us. The same is true with lighting. If there's a good interface that we can tap into to a lighting control system, then sure, we could include lighting in all of this. Yes.
Okay. You were talking about auto dealerships. Why is this service beneficial to them?
Yes, really retail in general is good because the service, you really want buildings that are open into the most expensive times of the day. So schools are not so good, right? Because most of the schools close down before the prices go crazy in California. But commercial customers, and I like car dealers because they're owner occupied and rich and they can make a decision, they're fun to deal with, but any retail store that's open late is a great contributor to the sort of relief of peak that we need in California.
Next question. When the battery energy storage systems are utilized to lower utility demand charges in a commercial facility, are they typically subject to standby rates by the utilities?
Oh boy. So the installation of solar batteries, anything like that, changes both the tariff that the customer is on and the usage patterns that should be going on in the building. Short answer is I don't know the answer to this question specifically, and I'm happy to take it offline, but it makes a big difference. A lot of customers get off of demand rates and on to time of use energy rates, especially in Southern California, when they go solar and battery.
Okay. There's a lot of questions coming in the chat that we may not have time for, but next question, what is the kilowatts that could be shifted in a commercial building, say 100,000 square feet?
100,000 square feet is probably 3 times the size of the building I was just showing, between 2 and 3 times as much as that. So a bit over 100 and less than 200 kilowatts of shiftable energy in a 100,000 square foot building.
Okay. And then do you track occupant satisfaction during the events?
These aren't events. This is a key issue for M&V in this space. I was just at the SEDMAC M&V forum. This is a very wide open question. There are no non-control days. We control 24/7, 365. We just control differently on days with very high price differences than those without very high price differences. So all you M&V folks with the big brains, I've done M&V. I don't know how to do this M&V. So the question is a great one and a huge open question.
Okay. And then the load shapes that you were sharing, are those averaged over all days of the month?
Those are averaged over all days of the month I was showing. Those are HVAC only. We also have, obviously, the grid meter. We calculate rather than meter HVAC so we can keep our costs down, but those are very good estimates of the HVAC.
Okay. More questions. We have one more minute before we hand it over to Albert. Have you had to replace smart thermostats with new smart thermostats to gain access to controls?
I would say in most cases, the thermostats are not, we don't have to replace them if they are already wireless communicating smart thermostats. So we can work with multiple different vendors of that sort. The ones that are programmed by hand, which might be smart but not communicating, yeah, we have to replace those because we need to be able to send a signal from space down into the building. So yeah, we would need to replace them regardless of how smart they are. It's more how communicative are they.
Okay. One more quick question, and then please see the chat because there's a lot of questions for you, John.
Yeah.
What HVAC system did you control for the pre-cooling strategy? Water to air or air to air?
Air to air.
Okay. Thank you, John.
Okay.
Lots of questions, like I said.
Yep.
All right. We'll hand it over to Albert.
Hi, can you hear me?
Yes. Yes.
Thank you.
Thank you.
So first, I do have a couple comments. I think this is perfect because I feel like my presentations, first, Albert Chiu, PG&E. I also work on demand response emerging technologies. I do feel like my study that we initiate in the fourth quarter of last year fits very well, with John's explanations on his project with Edison. First, I love the 4 Cs. I may borrow it in my future presentations, if John didn't trademark that. And then second,
Please, all yours.
thanks. And then second, I have a comment on that statement about energy efficiency is all about hardware, and demand response or load management is all about software. I think I agree to a certain degree. I think load management is hardware and software, right? Because a single speed pool pump, right, will have less load flexibility compared to a variable speed pool pump, right? There are hardwares out there that allow the customers, the aggregators, the control vendors, the utilities to have higher degree of flexibility due to the how the hardware is designed and built and its functions. So that's kind of, I just want to put it out there. I in general agree, but I do think that some of the hardware do provide higher load flexibility. Okay, so with that, I am going to talk about the OpenADL 3.0 study. It is, in general, a very similar study that Edison did with John, with the auto dealerships, but we are actually focusing on other small medium type of business, which is school. And I'll explain, that in the future, in a later slide. But on top of that, there are two major objectives of this study. First is to test the new OpenADL 3.0 study, 3.0 specification standard that was designed. It's a new standard which I'm going to go into a little more detail, and it was supposed to kind of design for it will be a better fit for dynamic rates such as the hourly pricing. And then second is to exactly try to identify if how this standard and how dynamic rates would apply to different type of customers, maybe including school that do not sometimes operate during the peak time, right? But maybe it's okay to look at school type of customers that do not operate peak time because dynamic rate is supposed to be 24/7. So with that, next slide, please. Okay, just want to give a high summary of what OpenADL is. It is an international standard, originally developed by funding from California Energy Commissions since 2002. And then LVNL was the first, was like, the people who, the lab who developed the original OpenADL. And then eventually it becomes OpenADL 1.0 and now 3.0. It is a open standard signal language for demand response and distributed energy resource. And it's mostly used for between utility to aggregators, system operator to aggregators, in this case, or maybe ISO, or even CCA, right? CCA, it's basically whoever owns the virtual top node, which can be utility, at the all the parties that I just talked about, and the VEN, it's the aggregators, and in some cases, the aggregator can also be the VTN, and then they send signal to VEN, and the VEN can be in the energy management system building level, on management system at the building level. Next slide, please. So, as I just mentioned, there is a VTN which manages the resource, creating the event, and also request reports during or after the event. And then the virtual end nodes would receive the events and respond to them, and generate reports, and mostly it's on the control demand side of the resource. I do want to point out that one of the most of the OpenADL use case is utility or ISO sending event signal to aggregators or energy management system. And what I mean by event signal is the event signals would usually include the start time, end time, and what kind of level we would like the what kind of level we would like the resource to respond. Is it 1, 2, 3, 4, 5, or is it high, medium, low, or or maybe can you reach certain kW of demand reductions? That kind of control. Okay. Although OpenADL in some unique case can handle direct no control type of signals, like, I would like the thermostat to go to, to reduce 2 degrees in hour 1 and to reduce 3 degrees in, hour 2 to 3. Although it can do that, most of the use case are either event signal or price signals. And we allow the aggregators and the energy management system to optimize the customer load based on those signals. So next slide, please. Okay, so the OpenADL 2.0 have been there for many years, more than 10 years, and it's being used internationally, probably in all continents. Basically, it's a very well adopted international standard, in Australia, New Zealand, England, Europe, many parts of Europe, and in many parts of Asia, Japan, Korea, even China. So the 2.0 definitely works. So why do we want to look at 3.0? Well, as many technology, we identify the needs to improve. So to compare to 3.0, it is using JSON, okay, instead of the previous program language, and then it continued to maintain the concept of OpenADL, which is, using the inform and motivate to provide information for aggregators and building energy management system to respond. And as I mentioned, it's truly support the dynamic rate and RTP signals, because we do see 2.0 not necessarily too adequate for that need. So that's why the OpenADL Alliance is developing this 3.0 standard. Next slide, please. So we are definitely working with, knowing that there are many standards out there, such as OCPP, BACnet, IEEE 2030.5, SunSpecs. We are definitely looking at how OpenADL, both 2.0 and 3.0s, would work better, will work better with all of these standards. IEEE is definitely, IEEE 2030.5, it's also required for many large-scale inverters in California. So it is, also a very important standard that, for distributed energy resource. But, in general, we realize that there's many standards and many different standards for different use. And, we are definitely trying to, rather than competing with them, the OpenADR standard is trying to collaborate and harmonize with all of these standards. Next. Okay, so as I mentioned, the study is, basically to help us understand the cost benefits of real-time rates, including the required infrastructure, manufacturer interest, and customer impact when using this OpenADR 3.0 standard. So the technology will test the energy management on the customer side. It will involve wireless sensors and different type of controllers, such as extract, and also software, which will be powered by machine learning. As I mentioned, we'll be enrolling 2 to 3 schools, and we will collaborate with the HFP pilot, which is the dynamic rig pilot that PG&E that has launched early this year to residential and non-residential and agriculture customers. So basically, we want use the OpenADR 3.0 language to understand how this new standard would help us to help customer to manage load on an hourly basis. So with that, I think that's my last slide, and I think there's some questions and questions.
Yes, you have a few
Yes.
questions here, Albert. So how is the reluctance from manufacturers to release device APIs limiting influence on open adoption? Do you have any suggestions? And then I'll pause there.
Right now, majority of demand response or load management programs, I try to use the term load management more because I feel like DR is evolving. So most of the load management programs that I feel like utilities engaging, it's partner with company like Energy Hub, AutoGrid, both those companies, and they develop APIs, and many more. So, there are many, like 20 companies that develop API with the different EV manufacturers. Okay, so we think that in the future, there's going to be multiple scenarios on how we do load management, and we see more and more customer adopting multiple technologies, and it is getting very challenging to do load management program that have that many API, right? We have an API with their battery, another API with their EV, and another API with their thermostat, and another API with pool pump. I mean, just one home, right? Or one building can have 4 to 5 API with different manufacturers, and they all control, difference, and they all have different preference, and they all charge difference on how, So we see the having an energy management system on the residential side and the commercial side is key for adoptions, high adoptions and high penetrations of DERs, and allowing utilities and ISO to leverage these DERs to control these technologies. And that energy management system, it's what we're targeting to send, open standard signal, right? So that we will allow, we'll let the energy management system within the home or within the buildings to develop those API. But then again, from the utility side, we'll send price signals or event signals to the energy management system using open standard. So that's how me personally envisions how things may work in the future.
Okay. Next question. What are the IOUs doing to develop a uniform pricing signal to enable CTA 2045 functionality?
Okay. The good news is the OpenADR Alliance on the OpenADR standard and also have the CTA 2045 specifications under the same alliance. So we are, the alliance is working on how to integrate more Pi signals capability into the CTA 2045, knowing that in the future, CTA 2045, it's what right now it's being widely adopted, in water heater, and we understand, that I don't think existing CTA 2045 is quite, it's able to respond to hourly Pi signals in a very sophisticated manner yet, but we are definitely looking into enhancing the CTA 25 to have that capability moving forward.
Great. Thank you, Albert. So we're just about out of time. There are a lot of questions in the Q&A and chat. I would like to ask our speakers to, if you have some time, to answer those questions. I'm going to hand it over to Ivy So, and I will also be launching a survey for you to provide some feedback to us. And thank you for joining us. And Ivy, take it away.
Thank you, Donna. Yeah, so I'm here to quickly share that exciting website that has been mentioned by Mark and Albert and Jeff here. This is that DRET website where all of those final reports from those projects that have been recently completed, save for that managed charging activity, are available up there. And then if they are building up to that final report at the end, they will also be hosted on this website as well as that ETCC website. So feel free to check this out and please do respond to our survey. Thank you.